Hello and welcome to another video of Learn with Mr. Ambassador. Today we'll be learning about practical consideration. Obviously, the more the number of plates used in fractionation, the higher the purity of the vapor product. For example, in air separation for very high purity nitrogen, it is not unusual. So it's like this. To install close to 90 plates in the upper column. The use of higher number of plates also carries with the disadvantage of higher pressure drop, which however means higher power consumption. The bubble cap trap. The original bubble cap trap used many years ago had certain advantages. It was cheap to construct, offered a very good liquid phase level, and had a good liquid retention whenever there are a wide variation or stoppage in vapor flow. Unfortunately, it had low efficiency, vapor diffusion in the liquid was poor, and the cost became prohibitive with the increase in air plant capacity. Sieve trays. The bubble cap soon gave way to more efficient perforated sieve tray fabricated with aluminum. It was more adaptable as well as more economical for high capacity plant over 300 T by D of oxygen. The variety of design for sieve trays are too numerous to describe. They have been used for oxygen plant with a capacity of over 1200 T by D. Even this tray, however, was rendered inefficient and costly for oxygen plant capacity over 1000 T by D. With a tray diameter of 4 to 5 meter, it became difficult and costly to construct a sieve tray that could hold a liquid phase absolute level. In other words, it was difficult to maintain a good equilibrium between the vapor and the liquid phase. The individual cost of such trays was anywhere from 2000 to 3000 per tray, and often higher. Sieve tray with a diameter of up to 5 meter have been installed in very large air separation plant. Structure packed. In recent past, however, designers have turned to the use of structured packing for large air separation plant, especially with higher power cost was involved. The technology of packed tower is not new. The use of random packing consists of ceramic or plastic ball rings has been around for decades. Structured packing has been used in refineries and chemical plants for the good numbers of years. It is only since 1980, however, that the industrial gas industry has ventured to use structured packing for both lower high pressure and upper lower pressure distillation column in air separation plant. The main objective has been to lower pressure drop across the column to reduce overall energy consumption. At the same time, a well-designed structure packing will also improve the mixing of the liquid and vapor phase for better rectification. The results from the field since 1990 have been encouraging. Pressure drop have been lowered dramatically and rectification has improved impressively. The technology of structure packing is quite simple and fairly well known. Thin stripes of aluminum or copper for a predetermined width are perforated and then corrugated. The stripe may be assembled either in a parallel manner or coiled in circular configuration. In either case, their overall geometric resembles a tray. Finally, these trays are installed in the column either in the shop or at the field. Designers have not yet agreed as to which type of assembly is better. The liquid reflux is fed from the top of the tower and distributed uniformly to the trays below by special design distributors. As packed towers are unusually tall, the designer has been considered to use of a number of distributors, as many as 5 in the lower pressure column, to remix the liquid and to correct any tendency to develop poor uniformity of distribution. The functioning of the structure packing tray is similar to that of reflux condenser, also known as Delphgamator. Sorry for that. Designed by Cloud in 1920. The reflux condenser is still in use today, especially in the recovery of crude argon. As a film of liquid reflux descends the vertical surface of the tray, it comes into intimate contact with the rising vapor and reaches equilibrium with it. As with a standard ship tray, heat exchanger occurs between the two phases. The more volatile component, nitrogen, in the liquid vaporizer and joins the ascendant vapor, whereas the less volatile component, oxygen, entertained by the rising vapor, condenses and joins the descending liquid towards the sump. This structure packing design permits the production of a very thin film of descending liquid in intimate contact at all time with a continuous flow of minute vapor bubbles throughout the entire packing with a minimal pressure drop. In fact, assuming an ideal design in one were to take a vertical slice across the tray, one will find a fairly constant thickness of the film and a constant vapor flow throughout the entire volume, which is the ultimate objective of the rectification process. The height of the packed tower divided by the number of theoretical plates is referred to as the height equivalent to a theoretical plate, or simply as the HTTP of the distillation tower. Thank you for watching. See you another video. Take care. Bye bye.